Morning, gang. We're here for daily lesson 12 for applied math. We're going to be looking at solving systems of equations today using the substitution method. Before we get into that method, we're going to look at how do we determine if a specific ordered pair is a solution to a given system. Our systems are going to contain two equations that have two variables. So we're going to check here in this first system to see if x is -4 and y is -1 is a solution to this entire system. For it to be a solution to the system, it needs to not only work for just one of the equations, but it needs to be true for both equations to be a solution to the entire system. So I'm going to check with the first equation here is -5 times x, which is -4, plus y, which is -1, equal to 19. -5 times -4 is +20, is 20, and -1 equal to 19. Yeah, it sure is. 19 does equal 19. So we're good with equation 1. We can't say yes to the overall system yet because it would also, -4, -1, would also have to work for equation 2. So let's check equation 2 is x, -4 minus 7 times y -1 equal to 3. Well, I got -4 and then -7 times -1 is +7. Does that equal 3? Yeah, 7 minus 4, 3 equals 3, so we're good. So we can say yes, -4, -1 is a solution to the given system. Taking a look at our second example here, we're going to check if x is 6 and y is 3 is a solution to the given system. -2x plus y is -11, and -x minus 9y is -15. So again, we're going to check both equations. Is -2 times x is 6 plus y 3 equal to -11? -2 times 6, -12 plus 3, is that equal to -11? -9, last time I checked, is not equal to -11. So, food for thought. If it does not work for the first equation, is there any way it can work for both? Let me think about that. No. So, you don't even have to check equation 2 in this scenario. Since it doesn't work for the first equation, there is no way it can work for both. We'll be right back with the substitution method. All right, let's take a look at solving the systems here using what we call the substitution method. Substitution, you can think of it kind of like a substitute teacher. You're going to take someone or some other value and put it in an equivalent value's place. So a substitute teacher is equivalent to a real teacher. Okay? If the real teacher, the normal teacher, is out for the day, the substitute comes in, takes the teacher's place, and conducts the learning environment for the day. What I'm going to do with substitution is I'm going to look for one of two things. First, I want to look and see if I have a solved equation. What I mean by that is, do I have an equation that says y equals or x equals everything else? If I do, like I'm going to see that I do in the first two examples, I am good to go. So as I look at example 1, timeout, we'll take a look at this single and positive thing here with examples 3 and 4, but I don't want to overwhelm you with all these terms when we don't need them right away. So what I mean by a solved equation, if I look at system 1, is both equations say y equals. Beautiful thing. So what I'm going to do is take what y is equal to, in this case x minus 4, I'm going to pick it up and then bring it down and put it in the place of y in equation 2. So my new second equation is I'm going to take x minus 4 and put it in place of y. So y is gone, x minus 4 comes in. So x minus 4 will equal -4x plus 26. I am now going to solve for the remaining variable, in this case x. So I'll add 4x to both sides. 1x and 4x will give me 5x minus 4 will equal 26. Add 4 to both sides. I'll have 5x is equal to 26 and 4, 30. Divide by 5. And my x value is going to equal 6. Now, how do I find the y value? Well, I'm going to take that x equals 6 and plug it into my solved equation right here. So y is going to be equal to x, which we just found is 6 minus 4. So y will equal 2. How do you know if you're right? Well, plug it into both equations and make sure you get yes and yes. So is y 2 equal to 6 minus 4? Yep, 6 minus 4 is 2. How about here? Is y 2 equal to negative 4 times 6, negative 24 and 26? 26 minus 24 is 2. We're good. Isn't that great? Lovely. Let's have a little more fun with example 2. Again, here I have a solved equation because I am told y equals x plus 2. So I'm going to take x plus 2, pick it up, and put it in place of y in my other equation. So here's what my new top equation is going to look like. I'm going to take x plus 2 and slide it up for y. Y is out. 2x plus x plus 2 will equal 8. I'm going to combine like terms, 2x and 1x to get 3x plus 2 is 8. Subtract 2 from both sides. 3x will equal 6. Divide by 3. And my x value is 2. Well, how do I find y? Well, again, I'm going to take that x equals 2 and plug that into my solved equation. So y equals x is 2 plus 2. Y equals 4. So those are my two solutions for the two equations. All right, examples 3 and 4. Notice here we do not have any solved equations. None of them say x equals nor y equals. Nothing. I've got multiple variables on one side. So we need to make a solved equation. Well, how do I do that? Well, the easiest way to make a solved equation is to look for a variable that is just like someone you'd maybe want to date or marry. Don't ever forget this advice. You want to look for someone or a variable that is single, again, no strings attached, single, ready to mingle, and positive. It's very much more enjoyable to be around a positive person than a negative person. And if someone isn't single, well, you don't want to be taking away someone else's boyfriend, girlfriend, whatever the case might be. So single and positive, that's what you're looking for. Here's what I mean by that. As I look at the third system, this x is single. There's no number in front of it, and it's positive. It's positive 1x. Same with this y. This y is single, no number in front of it, and positive. This x, not single. It's with the 3, so we're not going to worry about this x. And this y here is single and positive as well. So to mix it up a little, I'm going to try to hang out with this x, single and positive. So I'm going to get this x by itself, isolated. So to do that, I'm going to move positive y away by subtracting y from both sides, and I'll get x is equal to negative 3 minus y. So now I have the solved equation x equals, in this case, negative 3 minus y. So I'm going to take this x equals value, negative 3 minus y, pick it up, and put it in place of x right here. So look out. This x is being multiplied by 3. So I need to multiply this whole shebang here, negative 3 minus y, by 3. So that's going to look like 3 times, I need parentheses, and I'll use the distributive property, negative 3 minus y plus y equals 3. So I'll distribute 3 times negative 3, negative 9, minus 3y plus y will equal 3. My like terms, negative 3 and 1, will make negative 2y. Get my y term alone by adding 9 to both sides. Negative 2y will equal 3 plus 9, 12. Divide both sides by negative 2, and I will have y equals negative 6. Whew, halfway done. A little bit more than half the work, but I need to find also what x is equal to. Be careful. I'm going to go back to my solved equation right here, x equals, and plug in negative 6 for y. Be really careful. Y? Well, it's x equals negative 3 minus y, which is negative 6. So it's negative 3 minus negative 6. So that becomes plus. Negative 3 plus 6, 6 minus 3 is 3. So x is 3, y is negative 6. Whew, deep breath. Feeling good in the neighborhood. All right, again, single and positive, that's what you're looking for. As I look at example 4, I'm going to look, I don't have an x equals or a y equals equation, and I only have one choice for a variable that is single and positive. You might be thinking, what about this y? Well, it's single, but it's negative. That would be a last resort if you were desperate for marriage or one of those things. Again, take your time. Let it come to you. We don't want y in the first equation. It is single, but it's negative. And don't think you can change people. Nobody's that powerful. Everyone is who they are. So, y in the second equation is where we want to go. Why? Well, it is single. There's no number in front of it, and it's positive. So I'm going to get the y alone by subtracting 2x from both sides. So I'll have y equals 6 minus 2x. All right, ready or not, here we go. So I'm going to put 6 minus 2x in for y in the other equation, right here after this minus sign. So I'm going to have 3x minus, I need to take the opposite of y's value. So I'm going to put in parentheses here, 6 minus 2x will equal 9. So I'm going to take the opposite of y, the opposite of positive 6, which is negative 6. And then the opposite of negative 2x minus a negative will become plus 2x. That'll equal 9. So I have my like terms, 3x, 2x, which is 5x, minus 6 will equal 9. Add 6 to both sides. 5x will equal 15. Divide both sides by 5. X is 3. And then we'll find the y value by plugging in 3 for x into my solved equation, the y equals. So y equals 6 minus 2 times x is 3. So y equals 6 minus 2 times 3 is 6. 6 minus 6, 0. So there we have it. X is 3, y is 0. Beautiful, isn't it? All right. Fly on. Have a great one. Thanks for your time.